All right, so similar to yesterday, we're just going to kind of walk through, do it all three ways. The three things that we've now been doing here for the last few weeks, and should hopefully get similar answers, or at least try to do all of them all three ways. So if you look at this problem here, we should be on number 2, and it's giving you this x squared minus 8x plus a 2. And the question is asking, does this factor? So this would factor if we can come up with two numbers that multiply to be a 2. There's only one way to get a 2, correct? 1 and a 2. And if those could add together to give us a negative 8. So hopefully it wouldn't take you too long to realize there's no numbers that multiply to be 2 that are going to add up to be an 8. So with this, the answer to this question is no, this is not going to factor. So that's the first thing we want to understand. This is not going to work for us. All right, what that then means, we don't know the x-intercepts yet, because if we were able to factor this, yesterday when we factored number 1, set it equal to 0, those give us our x-intercepts very quickly. When we can't factor it, we don't know. What that also tells us, so even though we don't know just yet, we're going to be able to write those in a minute, so I'm not going to leave that question mark there indefinitely. However, what we would know is these are going to be irrational numbers. Our solutions are irrational. If it doesn't factor, that means our answers are irrational. Irrational, again, means we're going to get these square roots in our answer. Okay, so that's something now that we would anticipate when we go through doing it the other way. The vertex form and square roots in the quadratic formula, our final answers are now going to have square roots in them. If you went back in number 1, I think I erased it from yesterday. I don't think I saved it. But if we went back to our number 1, this worked out nicely. It factored. And when we did our quadratic formula, again, we don't get the ugly radicals. We get these nice whole numbers. Okay, so this one now we would anticipate getting some ugly numbers to work with here at the end. So the next thing we're going to do is we're going to bring this over here, and we want to put this into vertex form. All right, so we'll do that work on that side, and then we'll put it on that line. So vertex form is just our whole completing the square. So I'm going to do x squared minus an 8x, figure out what number I want to add in there to make a perfect square. And then whatever we add, we're going to subtract away from the 2 on the back. So to make that a perfect square, again, you don't have to draw it. But if we did the negative 8x, we would have had a negative 4 in this corner, 4x, a negative 4x in this corner. So that means I had a negative 4 and a negative 4. Those multiplied should give us a 16. So that would have been a plus 16 to make that a perfect square. We're going to subtract 16 from the backside then. So our vertex form should equal, when we have this here, we see that we had a x minus 4 on top and an x minus 4 on the side. So that's just x minus 4 squared. And then minus a 14 on the back. The nice thing about vertex form is we can look at that and know now our vertex is 4, negative 14. We can know that our line of symmetry is the vertical line x equals 4. And then the distance from our line of symmetry, we wouldn't be able to do that yet anyway, but we're not going to worry about it. Okay. Now, what I want us to do, though, is we're going to solve this. So this is what we're going to, let me leave that up here for a minute so you make sure we all got that. We can plot that point, but what we're going to do, did I not leave enough room here? So what we're going to do is we're going to take this guy. I'll try to squeeze it in right here. And we're going to use our square root, what we just quizzed on. So we'll cross that out. So now take this x minus 4 quantity squared minus 14. And instead of it setting equal to f of x, if we want our x-intercepts, all right, remember for our x-intercepts, the y value always is a 0. So we're going to, instead of the f of x, we're going to let that set equal to a 0. And then this is what we just quizzed on. Make this bigger. Where I want to add the 14 to the other side. So I would get 14 equals x minus 4 quantity squared. Once we get the squared by itself, we can now do our square root. So I'm going to do the square root of both sides, giving me x minus 4 all by itself on the right-hand side. So that's a good thing. When I do the square root on the other side, we know there were two numbers that I could have squared to get that, a positive and a negative. Then root 14, you could try to break that down. The only way to get a 14 is with a 2 and a 7. And since neither one of these is a perfect square, there's really no need for us to break that down. We can't go any further with it, so we just leave that. Then to solve for x, we're going to add 4 to both sides. So plus 4 and then plus 4. And then this is where we write our two different equations. So since we have a little room over here, I'm going to rewrite them over here. So I am going to do this positive root 14. So again, I'm going to take a positive root 14. And I'm going to add that 4. So that's one of our answers. And then this other answer should be, when we consider that root 14, we also have this little negative guy right there. So if this is a negative root 14, and then plus that 4, oops, that should be our second answer. So what that now allows us to do, we can now go back up here where we said we didn't know what these were. We just knew they were going to be irrational. That these are our answers now. Those are your x-intercepts. So one of them is the positive root 14 increased by 4. And the other one is a negative root 14 increased by a 4. And notice how we said we were going to get these ugly radical answers. We know that because it wouldn't factor. All right. All right. Then, looking at the homework this morning as I kind of graded these, we're pretty good at identifying the A, the B, and the C, going through it all. But at the very end, trying to simplify these, things get a little wonky. So take a second, because I think for the most part, we understand, here's our quadratic formula. We know what our A, B, and C are. All right, so I think that we're all good with. Pull it up. So our A should have been the 1, the B is the negative 8, and then the C was a 2. So 1, negative 8, and 2. Go ahead and plug those in and do those first couple steps, because the plugging in is pretty good. The initial step when we start to clean it up is pretty good, but then some of us have a really hard time at the end simplifying these. So see what you can get through here. If you looked on the assignment this morning as I did, a lot of you are going to see where I wrote, you're pretty good until the end, and then trying to simplify the fraction or the radical, things get a little crazy. And this one actually is pretty reasonable as these go. I'm going to pull up my calculator too while they're working. And then as a hint, your answer better be the same exact thing we just got, right? We did it a little bit differently with the square roots, whatever, but you should get the exact same answers. Okay. So as you're getting to the end of it, somehow it has to clean up to give us these answers here, right? The stuff that I'm highlighting right now, it has to give us these. And these are our answers regardless of the method we choose to solve it. So if we got these answers, the first method, the second method better yield the same exact thing. All right, so Did you get that, Jennifer? You done yet? Jennifer, did you get it? Yeah, okay. All right, so let's go ahead and get through this. Let's see what we got. So hopefully we've got, and this looking at homework seems reasonable. Here's our B. I think most of us are understanding that I don't just want the B. We want that to be the opposite of what B is. Most of us are plugging that in correctly as a positive 8, so that's good. Plus or a minus. Here's one thing that you want to be really, really careful now. Notice how I'm always putting this into parentheses, that B. I would strongly, strongly recommend you doing that because here's one of the issues that some people are having. There is a difference between a negative 8 squared. So if you plug this into your calculator as a negative 8 squared, that's going to give you a negative 64. Whereas if I plug in a quantity of a negative 8 squared, that's going to plug in or give you a positive 64. This is the one that we want right here. So if you're using a calculator, make sure you are putting that into parentheses so that that negative gets multiplied by itself and it yields a positive 64. Okay. One thing we haven't talked about, again, some of you will find this in your comments on that homework. Right now, we are not getting any negative numbers underneath this radical. If you get a negative number underneath the radical, that is a major problem. Let me show the calculator. We'll prove this to you. So we all know, the square root of 4 is easy. That's a 2. If I try to do the square root of a negative 4, my calculator will not like that at all. All right, so we can never get a negative number underneath the square root. It's something we will get to. I believe it's in this module at the end when that happens. But right now, if that happens, you're wrong. Okay, never get a negative number underneath that square root with where we're currently at. All right, so make sure you put this in the parentheses, and then you're going to have minus 4 times A times C. All of that over 2 times our A is a 1. So we get 8 plus or minus. So I've already said it with parentheses, that better give us a positive 64. And then minus 4 times 1. So just kind of go in order. A negative 4 and a 1 is a negative 4. That negative 4 times 2 is a negative 8. 2 times 1 is going to give you a 2. All right. So then from there, all we're going to be able to do in the next step is simplify 64 minus an 8, which is what, 56? And then all over 2. Now, this is not an obvious one. When I look at root 56, that is not one that probably jumps out at you. Like root 20, we've done enough to know that it's a 4 and a 5. That's pretty simple. But a root 56, it's probably going to take a little bit of practice, a little bit of playing around with your calculator possibly. But hopefully, what we would get for a 56 eventually is 4 times 14. If we did 4 times 14, that gives us 56. And we also get a nice perfect square right here. Yeah. Yep. Cam. All right, let's go back to here. Okay, so see how I had up here? Doesn't a negative 8 squared? Let me not even show you this. So let's write down what negative 8 squared means. So if I have a negative 8 squared, doesn't an exponent mean repeated multiplication? That I have a negative 8 times a negative 8? What is a negative multiplied by a negative going to be? Positive. So that's why that 64 ends up being a positive. Yep. Correct. So then that's why. So then I do 64 minus 8. And then that's going to give me 56. So right here, this better be a positive number. When it's completely condensed down, that has to be positive right now because we haven't talked anything about a negative number underneath our radical yet. Okay. Okay, so now in this next step, we have 8 plus or minus. This we now know is just a regular old 2. So we can break that down into a 2. And then what we've talked about, as long as, and there's a couple different routes we could take, this number here, this number here, and this number here, all the three terms that are not underneath a radical, as long as they have a common factor, then we can simplify that further. So this would reduce what goes into an 8, a 2, and a 2. The biggest number is 2. All right. So because of that, we reduce all those by 2. So 8 divided by 2 is a 4. 2 divided by 2 is a 1. And then our root 14. And then I should have my plus minus there. And then 2 divided by 2 there is a 1. So what if I don't write that 1, notice how I have 4 plus or a minus a root 14, just like we had at the top of the paper. Here's another way to do this because our simplifying isn't particularly good. So let me show you a different way to try to clean this up. The other thing we could also do is to just split this into two different fractions. Take 8 and divide it by this 2, plus or minus 2 root 14, and divide that by 2. If that's maybe easier for you to think of and see, maybe that's a better route for us to simplify, because then the 8 divided by the 2 is a 4, and then plus or a minus 2 divided by 2 is a 1, and then our root 14. All right. Okay. Any last questions on that guy? All right, all I want you to do in 3, because just seeing the quadratic formula last night, I'd like to end this week feeling somewhat confident that we're able to get through all of this. So take this function. We're not going to worry so much about all these other questions that we spent a lot of time on. Take this function, pop down here to the quadratic formula, and solve this function using the quadratic formula. Okay, so again, just got to go through it, see if we can get to the end, see if we understand how all this cleans up, because we're all pretty good about halfway through, and then we start having some little issues there. So let me write the function down here. All right, so that's our function, and we're just going to use the quadratic formula. What is going on right now? Oh, this thing's acting goofy again here. All right, I'll give you about 1 more minute because you're probably going to get a pretty decent sized number underneath there that we want to clean up. May take a little plugging away in the calculator. I'm not even sure what it is off the top of my head. I'm going to have to look myself. All right, I'm go ahead and get started. If you're pretty confident you plugged it in correctly, you got those first steps, you can continue to try to simplify this. If you can get all the way through this, this is not easy. Okay, there's a lot of work here, a lot of little places to make mistakes. It's something that you just need to be really careful and thorough with. Okay, a lot of stuff going on with these. So our first thing is we want the opposite of whatever b is, a negative b. So since our b was a positive 6, when we plug it in, it's going to become a negative 6. Then you'd have your plus minus, and then I'm going to do 6 squared minus 4 times a, which is 3, and then our c is a negative 4, and then all over 2 times a, which is 2 times 3. Negative 6 then, plus minus, so the 6 squared is 36. So again, you should not get a negative 12 out of this. If you get a negative 12 underneath your radical, then that can't be right. We're not getting any negatives right now. So what we should have first is a negative 4 times 3, should have been a negative 12 when we do those first two. And then that negative 12 gets multiplied by that negative 4. So a negative 12 times a negative 4 should be a positive 48. Okay? And then all of that gets divided by 6. So then from there, we can go ahead and add up 36 and 48. What is that? 84, I hope. All divided by 6. Now here's where it's a little guessing and checking. If you had a calculator, here's your perfect squares, right? 1 squared is a 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So the only numbers you should be testing are 1, 4, 9, 16, 25 to see if any of those go evenly into an 84. And the one that does the trick is actually not too big of a number. It should be this 4 right here. If I did a 4, so negative 6 plus or a minus, a 4 times a 21, wouldn't 4 times 21 give you an 84? 21 is kind of big, but you can only get a 21 with a 7 and a 3. Though neither one of those are perfect squares, so that's our biggest one. From there, you get your negative 6 plus or a minus. This becomes a 2 root 21 over 6. Not sure what happened there. And then now it's again up to you how you want to solve, how you want to simplify these. I'll do it both ways, so you can then kind of determine which way you think is better for you. So one option is to just look at these 3 terms, and all 3 of these terms better have a common factor if we want to reduce it, and they do. All 3 of those are divisible by 2. So in this next step, if I did a negative 6 divided by 2, that becomes a negative 3. 2 divided by 2 becomes a 1. And then the 6 divided by 2 should become a 3. So if you got that, you did it correct, which is really good. Okay, there's a lot going on. The other option is to come over here, and you could just split this up. Okay, like this. Negative 6 divided by negative 6 is a negative 1, plus or a minus. 2/6 would reduce down to a 1/3 root 21. So even though they might not look identical, either one of these answers is good. All right, yeah, Cam. Okay. So you're saying that's a good question, because I did see that a little bit on the assignment too. This is our final answer. I think what you're asking is, can I take these 3s and reduce those? Yeah. Okay. So think about it this way. Let me show you with some numbers. Let's say I do 4 plus 1 divided by 4. So if I ask you to simplify that right now, wouldn't you say that I've got to do 4 plus 1 is 5 and then divide that by 4? And then 5 quarters is 1.25. So if I gave you that as a decimal, it's 5.25. You agree with that? So this is good legal math. So now let's do what you're thinking and saying, can't I cancel these out? And if I did, wouldn't that just leave me with a 1 plus a 1? That gives me 2. Is that the same thing that I get doing it the other way? So this way is bad. However, so what you want to understand, if I do this, let's do 4 plus 2 over 4. Now that's 6 over 4. 6 quarters is $1.50. If I can divide it into both of them, what's 4 divided by 4? 1. Isn't 2 divided by 4 a half? Doesn't that then give me the 1.5 that I got up here also? So the only way we can reduce is if all 3 of these guys here are divisible by that number. And since this 1 was not, we couldn't go any further than that. Okay, it's a good question because a number of people tried to do that the other day. Okay, when I was looking at the homework. Okay, was that the last one? Oh, no, I'm on the wrong page. All right. Yeah, we may have to stop there because I don't think we're going to get another one done anyway. There was a number 4 though, right? Why is it not showing up? Do you guys have a number 4? I know, my number 4 is missing right there. That's weird. Yeah, I don't know what to tell you. All right. I'm going to cut you loose a little early here, give you a little gift for the weekend. You do have homework tonight, though, and it's just quadratic formulas again, so it's nothing necessarily new. So if you go to your homework packet, it is page 19. All I need you to do, don't worry about completing the square. So in that packet where it says, I can get it to right. What is going on with you right now? Don't worry about completing the square. I just want you to solve these by using the quadratic formula. I think it was 1 through 6 I needed you to do. And you're just going to do 1 through 6. All right. So I just want to see a few more of those quadratic formula only. And then that's going to be due on Monday. All right. Okay, that's it. We'll let you get out of here a little bit early. If you have any questions, let me know. But that's all I got. All right. Okay, we'll see you guys. We're not going to get through another one. Thank you too, Nick. We want to get through another one anyway, Mr. Kubowitz. They do take long. I don't know where my number 4 was at. Did you see that? It was not there. I wonder, there it is. So I moved some things to give myself a little bit more room to operate. That would have been a nice one too. We actually could have gotten that one done quick because it factors. Oh well.